Hello, welcome to Physics World. This is Mrs. Homberg, and today we're going to continue working with current electricity and try to understand the role of resistance and Ohm's law in circuits. What does it mean for there to be resistance? Something that's pushing back, that's getting in the way of what you want to do. And the analogy that's sometimes made is imagine all these little balls are trying to get down the hill. And there are all these things in the way. Think of it as like a big pinball machine with lots of levers pushing the balls all around and getting in the way of them flowing. So we can talk about Ohm's law, the intersection of voltage, current, and resistance. Ohm's law describes that relationship in a simple three-variable equation. V, voltage, equals I, current, times R, resistance. We know that each of these variables has its own units to be measured in. Voltage is measured in V volts, current is measured in A amperes, and resistance is measured in the omega symbol from the Greek alphabet, ohms. We can have a graphical interpretation as we work through these equations, and what would we notice? We would notice that if you keep R constant, if you lock R up, V is obviously proportional to I. As V increases, then I increases. And if you went to graph that after doing an experiment, you would see that as the voltage was increased, current went up as well. Likewise, let's say you kept your voltage constant and therefore changed current. As current goes up, resistance goes down. Or as current goes down, resistance goes up. This is in analyzing a small individual interaction. Let's work on some problems. Again, we have our core equation here, V equals IR. The current that flows in a circuit is directly related to energy transformations. And the higher the energy, the more current that can be provided. Let's look at the first problem. A flashlight has 3 batteries and a voltage of 4.5 volts. That means each battery is 1.5 volts, and you've used these small batteries probably in appliances, small pieces of equipment that you have. If the electrical resistance is 12 ohms, how much current flows? Well, let's determine what variables they've given us. They say it's 4.5 volts in terms of batteries. So that we're going to call our big capital V. We might want to use this for a little while so we get used to not thinking that's velocity. Electrical resistance is capital R, measured in ohms. And the question they're asking is about current. Well, those 3 variables are related in a very simple equation. V equals IR. We can rearrange our variables to isolate I equal to V over R, and then substitute and get our answer.